In this video lecture, we're going to take a look at the switch statement, which provides an alternate way of representing certain types of mutually exclusive selection logic. Okay, let's get started. Before we look at switch statements, let's first define what they are. The switch structure in Java provides a final type of selection logic, and for certain types of problems, it provides an alternative to using if-else-if structures. Both if-else-if and switch structures allow us to implement selection between multiple mutually exclusive options. You may hear it referred to in programming as a switch statement or a case statement, but these loosely refer to the same thing. The various cases of the switch statement represent the comparison of some variable or expression to certain types of fixed constant values. In other words, the key restriction on switch is that it can't be used for relational or logical comparisons. When we refer to known constant values, what we mean is that we can perform a switch on the following three types of constant values: integer values, excluding longs, char values, and string values. What's particularly nice about the switch statement is that because it works with predefined constant values, it can fork, or switch, directly to the relevant logical case. Unlike the if-else-if structure, it does not require us to check each and every logical case until we find the first match, which can lead to some nice execution efficiencies. Here's a generic flowchart for the switch statement. As with any other type of selection, this diamond represents a decision point. But now, instead of this being some condition which evaluates to a single Boolean value, now this represents a switch on some integer, char, or string, which will have some set of known constant values. So now the switch jumps directly to the applicable set of case statements without having to first evaluate each one until a match is found. Similar to the if-else-if structure, this default branch on the right corresponds to an else, or everything else, branch. And this set of statements in the next block gets executed no matter what. So you can think of this switch flowchart as if it were a turntable in some railroad switching yard, where you can send an engine down any specific track directly. Let's see what this looks like implemented in code. Here's a direct comparison of the exact same selection logic implemented as both an if-else-if structure and a switch structure. In both cases at the top, let's imagine we're working with some int value that gets set somehow. First, on the right, if we use an if-else-if structure for this, we need to check between some series of mutually exclusive possibilities using the equality operator like this. But notice that we have to check every case in succession until we find the first match. So for example, if our value was 4, we'd have to check this if, and this else if, and this else if until we reach this else case. But if we implement this using a switch statement, as seen here on the left, now we're performing the switch on the same int variable value, and then we can jump to the applicable case directly. So here, for that same value of 4, we can leap right to the default case without having to check all the preceding ones. This works in a switch statement because all these possible case options are known constant values, and they're already known at compile time, so this branching can be optimized. Once again, these case values have to be one of three types of things: integers, chars, or strings. If we can't express our problem in terms of such predefined alternatives, the switch statement won't work for us. To see a side-by-side comparison of switch versus if-else-if applied to the same problem, please take a moment now to pause this video and view the short code walkthrough video for selection switch comparison.java, which you'll find in the usual place. Open up this file in JGrasp so you can follow along. Come back to this video when you are finished. So here's the general form and operation of a switch statement. We begin with a switch keyword, followed by some expression within parentheses, then the open and close curly braces of the switch block proper. Inside the switch block, we have as many case statements as we wish, and they each involve some constant expression followed by a colon, then any number of case-specific statements. Each case is typically terminated with a break statement, with the default case as the last one, though as we'll see shortly, these are actually optional. This expression must be something that evaluates to one of the three permissible forms, either some integer, a char, or a string. It can be an equation or a method call, but it must evaluate to one of those three types. Then its value is compared to these case constants in order, and execution jumps directly to the first matching case. The statements found there are executed in order until a break statement is encountered, at which point the switch statement is completed. Now, it turns out that these break statements are actually optional, and we can use this to good advantage by grouping together statements that are common to multiple cases, a situation we refer to as stacking cases. So for example, if the statements of these first two cases were identical, we could group them by eliminating this first duplicate set of statements as well as this first break statement. Then these first two cases would appear next to each other, and this one common body of statements would be executed until this break was reached. We'll see some examples of this shortly. Finally, this default case is also optional, although it's usually good practice to include it so that any oddball cases may be handled safely. Although a break statement at the end of any case is optional, a very common gotcha using switch is to forget using a break statement at the end of a case under nominal conditions. In this situation, the statements of a particular case are executed, but then nothing stops execution from continuing on to the next case, whose statements will also be executed, a situation sometimes known as fall-through. This can sometimes be a sneaky logic bug to find in your code, but the debugger can help you isolate this. It's usually a good coding practice to always include a break statement in each case until you decide otherwise that it's not needed. When trying to decide between using if, else if, and switch, consider what kind of logical decision making you need to make. If your logic calls for relative comparison between values or some kind of compound logic, it's probably best to use if, else if. But if you're trying to decide between multiple specific known integer, char, or string values, this may be a good candidate for switch. One very common usage for switch comes in handling user keyboard inputs, where the various cases will then correspond to specific keystrokes. We'll see some example code for this shortly, and you'll be doing this in an upcoming program. Of course, there is still the matter of keystroke case sensitivity to handle, but we'll show how to deal with this in the examples. I have several good examples of using switch with all three permissible types of values, but these are each just a bit too lengthy to be presented as lecture slides. However, each one nicely demonstrates various aspects of using switch, as indicated here. So please take some time now to pause this video and view the short code walkthrough videos for the following three examples, which you'll find in the usual place. Open up these files in JGrasp so you can follow along. These examples should give you plenty of examples demonstrating how to use switch in a program. Feel free to mess around with these files on your own because you can always re-download them. And with all that, hopefully you now understand the switch statement.